is Reese, and I'm responsible for measuring the volume.
My name is Brady, and I'm responsible for measuring the weight of the tube and the water.
I'm David. I'm in charge of the temperature.
My name is Daniel, and I'm responsible for communicating with the professor, turning in our project, and acquiring the materials for this experiment.
And my name is Hayden Hoxie. I recorded all the video for this project, and I'm the video editor for the project.
I'm going to measure the weight with the water, the syringe, and the gum. And we're at 26 grams.
Just measuring the starting temperature of the water so that we know how much it increases and how much it takes for us to get from each phase. 57.5. 98.3.
And the final volume is about 15.8.
Here we have our experiment set up. On the left is our thermometer to measure the temperature of the water inside of the pot, and on the right is our tongs. They're used to grab the syringe out of the water so we can measure the volume. Here's a picture of the syringe right after the experiment has ended. You can see the vapor and the water in the same syringe. Here we have an image of a couple minutes later after it's cooled down. There's less vapor and more water. And finally, we have a picture of our syringe of just water. This is after it's cooled down and it's condensated, and there are 10 milliliters of water, which is what we started with. Finally, we have an image of all of our data recorded throughout this experiment. Here we have a chart showing the rise of temperature over time. As expected, the temperature began to plateau right around the boiling point of water. A similar plateau can be seen here in the specific volume chart. Here, our specific volume versus temperature chart is a great example of the two-state diagram on the right. This plateau we see in our temperature versus specific volume chart is actually the area under the curve shown by this arrow here. This is where both the vapor and the boiling water both existed within our syringe.
And I'm the one who got everything together for this experiment. The purpose of this experiment is to demonstrate the connection between volume, temperature, and pressure inside of the sealed chamber when heat is added into it or pressure is added. In our case, it will be heat, and to show the volume is changing over time. So in this experiment, we have a syringe, we have putty, and we're going to insert both of those, or we're going to fill the syringe with water, and we're going to put putty on the tip so that it blocks all of the water that could exit when the heat is applied. Then we're going to put it in a bowl of boiling water so the heat from the boiling water is transferred into the syringe itself. Then, inside the syringe, the water will boil and turn into vapor. In this case, this will increase the pressure inside of the syringe and thus increase the volume by pushing on the piston at the other side. We'll use this experiment to show that as the temperature and heat inside of the syringe increase, the volume will increase as well. Hopefully, by the end of the experiment, we will have loads of evidence to show that there is a connection in between heat, pressure, and temperature. At the end of the experiment, we will get all of our data together and combine it into a table and a graph to show that the relationship between these three things. We hope that this experiment adds on to the understanding that you may have of thermodynamics and this in particular.